The branch we typically build in our workflow is our release branch. So this is any of our sprints. And you could also do master as well if you are truly continuously integrating. CI should be literally as quick as possible. If you can get it down to seconds, that's great. Minutes are fine. Hours is where it becomes a problem because then your builds start to stack up. Store your build in a repo of all your binaries. So what we do is we store our actual outputted builds inside of S3, and we only build once. We never build again. Once that builds up on S3, we never touch the source code again. We literally just deploy out the binary.
So, okay, so you do the build, you check it all into S3, and then you pull from there and release?
Yes. The reason for this is because a lot of people like set up what's called branch by environment. And the problem with that is that, one, there's merging problems, and two, is that it's possible that the build could screw up and you not notice it because you think it works fine in dev and stage, that it has to be a server problem when it could just be, oh, you're missing a couple of bytes. And this has happened. Not to me, but I've read about it happening to other people. There's a book I'll recommend at the end. It's by Jez Humble. I don't know if you ever heard of him. He wrote basically the Bible on continuous delivery, where he talks about a company that's kind of like a supermarket. They released this code for their registers, and it worked fine in their dev and it worked fine in their stage, but in their prod it was causing all kinds of hell and they couldn't figure it out. Well, when they looked at the actual binaries, it was like 5 bytes short of the other environments. So somehow the build process cut off 5 bytes. If you're deploying the same binaries into each environment, you know that for the most part, you should be able to eliminate the binaries being the problem.
Wait, so you're building once, say, in dev, and then propagating binaries, or you're rebuilding the binaries each time?
No. I only build my binaries once. And I store them. So if they're in release mode, so if they need to be signed or whatever, I do it once.
Interesting. And then you pull them down to check on QA, and then you pull them down to check on prod.
Yes, then my orchestrator will send them out to the environments.
When you're trusting the dev build of them.
Well, we don't. When you mean by dev build, I'm having a feeling that you're saying you're putting like trace statements and things like that in your dev build. Are you talking about debug or versus
so
release?
Who does the final release build then, and what branch does it do?
We do our final release build on the binaries that get checked in under that release branch.
And then you do QA and everything on those?
Yes. So, but they're in release mode. They're not in debug. We don't have debug switches and stuff like that on. If we need to modify that, we modify it at configuration level, but we try to make it so that it kicks the process all the way back to dev. We don't like to get in the, we've gotten to a void for a long time with having to debug in production if there's a problem, or having to debug in any environment because we can kick it back all the way to our local. The reason for this is that we really want to build confidence in our binaries. If they work in dev and we put them in QA, it should work in QA. If it works in QA, it should work in stage. If it works in stage, it should work in production. The environment will change as far as where it is. It's not going to change with what it's doing. So if you have a SQL server, you're going to have a SQL server in your dev environment. If you have a SQL server, you're going to have a SQL server in your stage environment. If you have a load balancer, you'll have those as well. And the size of the environment might change. So obviously when we're in production, we might have 100 servers. We don't need that in stage. We don't need that in dev. 2 servers is fine as long as it mirrors what the environment should look like. This is what it kind of looks like in our build repository. Now, what we do right now, and I think we're going to try to eliminate the process because we're going to mostly focus on artifacts, is that we store the binary multiple times in each environment. It's the same build, but the packages are copied into folders because it made it easy to pull them down. Because I also have a script that when our servers boot for the first time, it grabs the build from the latest build that it found in S3. So it's easy to separate based on the environment. If we look at this from a Go CD perspective, this is what we kind of see. Now in Go CD and other CI servers, kind of like Team City, You can store artifacts, and you can store it directly on the actual server, or you can automate it to where it pushes it out to GitHub and then have it, the artifact be in GitHub and just pull it down from there. Let's play a really quick game. Can anyone spot the difference? This is an easy game.
3 of the ducks are going the wrong way.
Mm-hmm. You might be asking, like, why would I ask such a ridiculous question? Because, there's only 3 things that are wrong with the ducks, and they're pretty easy to find. Well, environment problems have a tendency of plaguing developers' times. I was at the same job that didn't use good source control tactics, and we were trying to isolate a problem with one of our production applications to where if a user goes to sign up for it, it would cause it to yellow screen. But when they went to dev and QA, when we tested it, it didn't do the same thing. We pulled our hair out of this, must have tested and tried to find different things in all the environments. And it probably took a couple of days to when someone actually just started looking at the patch level. Well, it turns out in dev and stage, there was a patch for .NET Framework 4.5 that was it was some ancillary patch. And what the problem was is that the production server didn't have the patch. So every time you tried using it, it would yellow screen. And it was weird. We could never reproduce it in our other environments. And it was just because of this one single patch. Well, it would have been a lot easier had we just been able to torch the server and start over and get it back to what we consider our golden master. We didn't do that. We were trying to treat our servers like pets, or we were trying to say, okay, what's the problem? How can I keep the life of this server? So when you're looking at environments from a configuration management perspective, being able to torch your old environments and just starting up new is a lot easier. It takes less time. You can see exactly where the problem is, and you can debug from there. You're not spending days or weeks trying to figure out what's the difference. For my current job, if we have any problem, we kill the environment and restart the server, and it will grab everything that's required for that box, including we store patches in what we call a golden master, but it'll install IIS, it'll grab the website, it'll install the jobs that it needs to do, and it'll add it to the load balancer. This is all something that happens at a push of a button. We don't do anything. And anyone can really do it, to be honest. The strategies to get to here is that we build a golden master. Since we use AWS, we use these things called AMI. They're Amazon Managed Images, basically. And what they look like is like VDKs. And this is where we put our patches on the server, and we originate in dev and test to make sure it works. And then we go to stage and we go to production. It's the same golden master we're using across all our environments, so we're not wondering, okay, one's got the patch, one doesn't. When we're dealing with the configuration of the boxes, like if it needs to have IAS, or if it needs to have application server roles, or if it needs to have, you can even install things like remote desktop access, or what's that damn thing? Terminal services. If you have applications that, WinForm applications, you can do those through scripts like chef scripts, to where it'll push the configuration and figure out how it needs to work. Now, the Microsoft end for this is kind of sucked. I'll be honest, it takes about 15 minutes to, boot a server, and that kind of sucks if you have, a high-scale site that you got to deal with millions of transactions. With 2016, this is going to be a lot better with server core, I think it is, Nano, to where you should be able to spin up a server in about 15 seconds. This is where everything will be going in the future. The point of all this is that you should be trying to lessen the time to getting back to a working build. If your environment for any reason is not working, it's far easier to just say, okay, I'm not going to worry about it at all. I'm just going to go back to step A, try to get it up and running, and then everything should work. Again, prefer to destroy environments than keeping them, and then kind of treating them as cattle, not pets. And what I mean by cattle is that cattle will have a couple of properties. If you look at a cattle that's on a farm, they've got a tag on their ear that just says this is number 106, whatever. They've got no name. We just keep them for as long as we need them. If we don't need them anymore, we kill them and get another cattle. And that's pretty much it. If they're sick, just get rid of them. With pets, we give them a name. We give them love and stuff like that. Like if you have a server, you name it like Wookiee or something like that, then someone has to name it that to get it back into a working order. With pets, you'll try to nurse them back to health rather than just let them die. So that's the way that kind of comes from. Everything, again, should be promoted from source control. This includes your configuration. So configuration management can be managed by creating a set of chef scripts or salt scripts or PowerShell DSC scripts and storing those in source code. Every change to your environment should be originating in source control. You version these configurations, at least we do, with tags or labels if you're using TFS end. That way you can get back to the specific environment you need to be to. We also keep a change log of anything that's changed so that future developers and future ops staff know how it works. The time to resolution, because of that, becomes significantly less. We're no longer dealing in days, we're dealing in seconds to get back to a working environment. We can deploy to environments like disaster recovery. Disaster recovery is not a fun topic, and it's mostly haphazard depending on what you're deploying. Like if it needs to work, everyone will make sure it works. But if it's an application like say a web application that only some customers use, to where ops staff is not going to really test it if they do a disaster recovery, then you might find out when you actually have to, when the server farm burns down, you have to then go test it and it doesn't work. Your scripts on the configuration side will become living documentation. When someone updates it, it'll be put into source control. Everyone can read it. It's there for everyone to see and everyone to comment on and people to make changes to. We no longer have to worry about if Mike leaves the company, if we'll be able to do this without him, or will we have to hire a new person and then they'll have to spend a couple of hours figuring out what Mike actually did. We'll be building confidence so that we can recover when failure eventually will happen. Now I bring up creating a symbolic link because most people, when they do deployments, will find out that, like when you're copying over files for IIS, that a file is locked or something like that. Doing a symbolic link is a very easy way of preventing that. So if we were to look at pipelines, because these are all a series of pipelines that are linked together, what we'll usually do in dev is keep it simple. We literally just want to get from our build environment out into dev, so we'll do our deployment and we'll keep it the same way across every single environment. We're not going to differ in how we're going to do our deployment. We're not going to like add a stage in production that we're not going to do in dev. Code should be more or less exactly the same. That's the whole entire reason why we have the build once methodology, but the config values will be different. And we'll usually pull those configs from like an environment variable or from a configuration store. Your dev pipeline, you should always really run your smoke tests. And for any environment, you should run smoke tests. Smoke tests literally just go to a website, make sure that it works, make sure that it's able to go over port 80 or whatever your application is doing. Just putting electricity to the wire and see if it smokes or not. Typically, your QA people would pull from this environment by just clicking a button, and then the next environment, of course, we're going to QA. Here's where they would do a little bit more mature testing to make sure that it's in line with user requirements and anything that might be something the developer didn't think of, expectations. For example, if you click on a button and you're holding space, it does something really wacky. This is kind of where we would check this out. Here's also where you'd probably run a full regression suite, and this is where you probably need to get sign off of your QA manager or QA analyst to make sure that the stage is actually complete. From there, we kind of have our user acceptance testing. Our users will be able to pull out our builds, and then they'll be able to do more attention to detail. At this point, they'll pull it through the ringer and tell you exactly what they need. Feature or bug should be, for the most part, complete, and your stakeholders are usually your customer or your manager. Then, of course, you have your staging pipeline, which your whole entire stakeholders is your DBA or your IT manager. This is the whole entire to make sure that if we were to put in production, this would actually go without a hitch. That's why they're the major stakeholders, because they have to deal with the problem if you don't, if it doesn't work like it's supposed to. You would actually then roll out to your production. There are some strategies for doing this. You could do something like an active deployment and just deploy out to all your boxes and hope everything works. But maybe you're a little bit bigger. Microsoft uses, for their Azure platform, they use canary deployments, to where they'll actually deploy to a few key customers and test and get feedback before they actually then roll it out to the rest of their customers. Another strategy is a blue-green deployment, where you literally have the version A and version B on one, on a front-end server and B on a back-end server, and then what you're basically doing is switching out those servers. So let's say I have version 1.2 and I have version 1.3 in the back. After all of them are loaded and all my cache is ready to go, and everything's all systems go, just switch it, and then they all point to B instead of A. These are pretty easy to set up in some of the tools. I know canary deployment and blue-green deployment can be done through Octopus, which is a commercial product for .NET specifically. Now, with anything, it's important that you can actually measure. This comes more from the Deming cycle of plan, measure, do. But when you're doing a deployment, you need to look to see how long it actually took to deploy. If it takes more time to deploy one version versus less, you're probably not doing something right or something's amiss. You can also measure if your response time is better or worse to determine if your deployment is getting you towards better software. You can also look at average error per deployment and then show spots in the API or high transactional count. We use a tool at work called New Relic, which kind of shows us visually what it looks like. So we can look at transaction count for the current application and see exactly where it is. If we see higher loads or we see higher error counts, we can determine if the deployment's actually botched or not. We can also look at indicators if our logging instrumentation is just going through the roof of things that are wrong. We can deal with that as well. Once we've deployed to our production environment, what we typically do is we tag our changes in source control. Through GitHub, they have a nice feature. It's called building a release. So you can just create a release and it tags it for you, and then you can grab zip copies of the source code from GitHub directly. Whenever a problem arises with the release in production, we typically branch off that tag. That's the whole entire reason why we tag the release that we actually send to production. And then we always add release notes on what's changed so we can determine, if we're making progress or not. There is a caveat to all this. Things don't always go well. In fact, if you wait over time, bad things can happen. Or you can do crazy and stupid things. So you'll usually have to do a rollback. And sometimes this can be more painful than the deployment itself, because you don't know if the code will actually work. If you upgraded the database, how do you get back to a state? So you have to make your rollbacks just as easy as your promotion process. If you don't, the whole entire thing is wasted. We've had to roll back our product a total of 4 times, I think. And being able to do it with one click and not having to worry about if it won't work or not was key. So the way we were able to get there is we deploy more often, and then when we have to roll back, we know it will work. One case when we roll forward and we found out that there was new code added that was adding a whole bunch of latency. In fact, every single request was taking almost 3 seconds. Now that doesn't seem like a lot of time, but our requests to our servers have to be able to respond within about 20 milliseconds. So this was on an order of magnitude higher than what we were doing. What we were able to do is switch back the version to the old version, get the servers running again, and then isolate what the cause was. It turns out when we started doing some root cause analysis that a programmer introduced a loop within a loop within a loop that was executing about 9,000 iterations for every request. 900,000 iterations for every request was just choking our throughput. If you have to roll back for any reason, you should of course get manual approvals and always respect them. Something that we do in our process that we promote is we actually notify people via Slack, so everyone knows when we're doing deployments. And that's just like a simple script or something like that. Always investigate the issue and make sure the software is stable and working first before trying to get it out to production. A lot of people like to shortcut directly to production, usually at the angst of project managers, to not do their testing. Well, if you've got a break fix that's big, you should always go back to dev and try to figure out if to actually fix the issue rather than sending it out directly to prod. A key note is to kind of limit the amount of time you actually spend debugging in production. Prefer to use like trace logs and things like that rather than hooking up an actual trace system from your debugger. You'll always want to kick off a new pipeline. This pipeline's dead as far as you're concerned. You're never going to use it again because it's bad software.
When you say this pipeline is dead, what do you mean exactly?
So what I mean exactly is here. Let's go back.
Because you talked about multiple different pipelines, but to me that's just basically process. So,
Okay, see, this is a series of pipelines. So there's the build step integration pipeline, there's dev, there's stage, there's prod. So this is one version. This is like it's like 1.3640.
okay, so when you do a new release, the whole deal.
Yeah, this version's dead.
Okay, so you're just beginning to build a new version.
Yes, it's a
Okay,
new build.
all right.
Some people will try to patch the old build and then send that out. You should use all your diagnostics that you have available to you. Trace logs are great. You can up the trace level on your logs and find out exactly where the issue is. Tools like Logstash will be extremely helpful to you. Kibana can help you as well. Analyze and examine your logs, and that includes Windows trace logs in addition to your trace logs, and then analyze performance counters. We have actually, I've never been able to figure out like what performance counters would be useful, but we were actually able to figure out a problem that we were having with our main application server. So when we do our testing for our service that we offer, we test about 2,000 connections per second. We were hitting a wall when we would add a server to our load balancer to where it was just resource pegged at 700 connections no matter what we did. It would just fall down as soon as we went to 700 connections. By looking at the performance counters, we were able to see that there was a whole bunch of network I/O and there was a whole bunch of disk activity and network activity, or not network, processor activity that was happening. When we looked at it and we started correlating, we found out that we had actual diagnostics set for Microsoft ETW, which is the event tracing for Windows. And that was, even though it was just going to null, it wasn't going anywhere, it was just causing us to, our connections were just tracing every single time someone connected. So we would never be able to get over 700 connections. By turning that off, we were able to scale to about 2,000 connections. Being able to see it would actually helped. I mean, being able to see it across a bunch of servers said like, okay, there's definitely something wrong with the code. This isn't an environment issue, this isn't an AWS issue, this is a code issue. And then analyze system trace messages. So I've talked a lot about process, but you're probably wondering like, you know, what are the actual tools that I can actually use to get some of this stuff done? When we talk about configuration management, there's a number of tools. In fact, you know, there's more mature tools like Chef and Puppet, and there's less mature tools like Salt. You know, DSC is brand new on the block. DSC, for those who don't know, does anyone write PowerShell scripts? Does anyone use PowerShell? No? Okay, that's a shame. So DSC stands for Desired State Configuration. What you can basically do is tell the computer how it should configure itself, and Windows will actually say, okay, I'm going to configure it myself like that. I'm going to put, you know, IIS role installed. I'm going to put this file in this specific place. I'm going to add this account for this specific user. And if it ever gets out of sync, which it could by a user logging onto the server, it will actually recreate all those things in 30-minute increments. So if the user gets deleted, it'll re-add the user if it's under a PowerShell DSC profile. Puppet and Chef kind of do the same thing. They maintain to make sure that the the configuration is maintained. System Center is more of a tool that actually does use DSC as its provider to maintain the servers. System Center is a commercial tool that's sold by Microsoft that it can manage your whole entire operations system. For deployment, there's a number of tools. You can use Chef's deployment tool. In fact, at my current job, that's what we currently do. We create a series of Chef scripts, and then that's what does the deployment. GoCD is another option that you can actually use as an orchestrator and deployment tool. The way GoCD works is it works through a series of agents, and depending on what environment and which pipeline they're associated to is how they'll be able to grab the configuration for the or for the environment variables and pull that from your artifact repository like S3, or you can even use Go as itself, or you can use like a file share or something like that, and then it'll install the build for you and make sure that it's running and going well. You can also use GoCD in the term of Docker, so you can actually install the GoCD agent on Docker and then spin up a new Docker instance and have that do your build, or have it do your configuration for your environment. Octopus Deploy is another tool that's available on the Windows side. I haven't used the tool, but I know that friends who have, that they say they really like it. It uses a series of PowerShell scripts to be able to automate your whole entire process with deployment. They use these things called tentacles, which grab out these NuGet packages and install the builds on the servers. And then it has a nice little web admin that you can go in and click which environment you want a build to go to, or how you want it to be deployed, and what configuration should be bound to it. Jenkins is one of the ones that a lot of open source shops use. You can create deployment pipelines with it through a series of plugins. There's tons of plugins for Jenkins. It's a great tool for that, and it can be used for CI and deployment. There's also cloud-based systems. If you have AWS, they have co-deploy, which allows you to deploy to your servers, or you can use something like Elastic Beanstalk, or I don't know if Microsoft, well, they have Release Manager on the Microsoft side, which I think is being integrated with the Azure side. For CI servers, there's Cruise Control and cruisecontrol.net. These are more legacy. I wouldn't recommend it, to be honest, because what Cruise Control codebase is actually the base code for GoCD. And GoCD is actually a lot more visual and nicer. Cruise Control, you had to do a lot of XML configuration in order to get your CI server to work. TeamCity is also a very nice one. It's very easy to use. Any newbie user can probably get up to it really quickly. Jenkins is also another nice one, very easy to use. TFS, it's good if you're a complete Microsoft shop. If not, it might be a little bit more difficult to use. The key thing with TFS, if you're doing MS Build, is that it's not going to respect it. So, for monitoring, there's tons of options. CloudWatch is one option. New Relic is another option. It's expensive though. It's about $199 per server that you have it installed. Microsoft Application Insights, I don't know how much the pricing is, but that's also another good tool if you want to know how your code's actually being used and what the latency is. You can use ETW in Windows directly, or you can use something like syslog and output it to something like Loggly. Loggly is a syslog as a service kind of system, to where you can actually look through your event log, or through the syslog messages that you send from your servers or your applications, and get information about it. There's tons of automation tools out there. The Windows side, there's PowerShell. You can of course do command executable, kickstart scripts if you want to go old school. Linux, there's Bash, Ruby, Chef, Python automation tools. And then for environment config tools, there's really only two right now, which is Vagrant and Docker. Docker just got released for Windows in 2016. However, it's extremely finicky right now and not exactly production ready. But it is out there, and you can install it to install your IIS. And is anyone familiar with what Docker is? No? What it is a way for you to basically add version control into your environment. Like, you basically create a Docker container that has your application ready to go. You just install it and it's ready to go. You don't have to worry about patching it or anything like that. These are containers that live on the hardware and run. They're more powerful than virtualization because they don't have a kernel. They share a kernel, and they're faster because they can be ran on bare metal. They have the benefit of virtualization because they're isolated at the network and file system level. You can, for example, you can have a Linux where you have like a var log or something like that. Your Docker containers should never be able to write to that same var log if they're running different Docker containers. So if you have one Docker container that's running MySQL, another Docker container that's running like some application, they'll be on the same hardware, but they'll never write to that same location, like, even if they would if they were installed in that same computer. Vagrant is a hell of a tool as well if you want to be able to create an environment on your local and automate it and make sure that you can set it up. We use Vagrant a lot where I work because that's how we set up our tools for Elasticsearch, Redis, and Memcache. It makes it easy to do it. For continuous delivery tools, if you're going on site, GoCD is open source and free. Octopus Deploy is another good one as well. For CI Cloud, there's Circle CI and AppVoyeur. AppVoyeur is CI as a service basically for Windows. So what they'll do is that they'll build your code and then they'll also deploy it, and then they have basically a framework that's like a workflow that they'll do your deployment for you. If you're interested in further reading about the topic, I seriously recommend Continuous Delivery, reliable software releases through build, test, and deployment automation. It's by Jez Humble. It's a great book. And then the Phoenix Project, Novel IT about DevOps, and kind of sells the whole entire thing of why you should automate. So if there's any questions, I'll take them. Not? Sure.
All right, that's it for this episode. You can find links to Mike's blog as well as the SoCal.net users group homepage down in the description below. Be sure to subscribe to CodePorn, and if you like this video, click that like button or leave a comment and let us know what you think. Thanks for watching.